I can see the mood is so-and-so this morning. Third week in the semester. Things starting to sharpen up a little bit. Still a long way to go. And yeah, that's the tough part. We have to hang in there now. Don't give up. Here's how they view it on this one of these web pages on the intelligence scores. Actually, they say 68%, and then they say 96%. Actually, the better rounding is to say 95, as I said. It's because they round off these values to 14 and 34, and then they have to say 96 for the numbers to match. But that's a rounding thing. Let's move on with some more examples of working with calculating stuff with the normal distribution. We just saw this using the standard normal. Now we're going to have a more general normal. So in this case, we have some x, which is normally distributed with mu and sigma squared. This is just the way we put it. It's just code for saying that the mean is 280,000 Danish kroner and the standard deviation is 10,000 Danish kroner. First of all, we can use the fact that we don't have to deal with all the zeros. Let's just say 280. Then I'm going to do a sketch. Before I calculate anything, I already know, more or less, what is the distribution that I have been given as a model for the situation. Because I have learned that if I take 2 standard deviation steps to the right, that means 10,000 Danish kroner. That would be up to 300. And if I take 2 by 10, that is 20 to the left, that would be 260,000. If I do this, this is my sketch of the distribution that I have been given as a model for the situation. That is to say that approximately 95, now I almost answer my own question here, approximately 95% of all teachers have a salary between 260 and 300,000 kroner. I believe this is probably not updated numbers, or we should take very young teachers, or it's just what they will get in the future when the financial crisis really hits us all and we have to go down. Like in California, all university employees at the state universities, which include some of the major universities in California, had a decrease of 15%. They were not really asked. They would just say, hey, you have a decrease of salary of 15%. And maybe they're facing another one. Let's hope we don't get there in our country, like a Greece situation in California. That's a bit not nice to know, since we like to hook up on the Americans on this one also. Anyway, that was a sidestep, sorry. What is the probability that a randomly selected teacher earns more than 300,000? And now I've removed all the thousands and just working with 300. Here is the general rule for this is a statement that is on a general normal distribution. This, we can rephrase it. We can use this standardization rule. And here is how it goes. That would be the same as taking the standard normal, subtracting the mean from the number from the relevant number, and dividing by the standard deviation. This is the transformation. Now I jump back. This is the transformation I showed you on this slide 16. This was shown in general formulas. Here I'm putting it into play in a specific situation. So I can compute this number. This is like, I should emphasize then, this is the set. Yes, a question?
Why is it square root 10?
Why is it square root 10? This is because I changed the story into that the mean was 280 and the standard deviation, sigma, was 10,000. And there's the 10. And then I made a mistake here. Thank you. So the real would be like this. It's actually divided by 10. Sorry. Thank you. Who made the question? Thank you. This becomes minus 20 divided by 10. That would be capital Z larger than or equal to minus 2. And this was the standard normal. We already know this number. This is the number we found a few minutes ago, just before the break. This was almost 2.5%, right? This is where this 95% comes from. This is actually, you could say, 2.3%. And this is, as we sometimes, when we do sort of approximate thinking here, we call this 2.5%, meaning that within plus minus 2, we have 95%. Another question. 2 instead of minus 2. Oh, yeah. Yes, you are right. It should be plus 2, meaning that the correct answer would be 1 minus this, which means that... What is going wrong here? No. Now I'm correct, right? Now otherwise I would have... so this is, as I said, it's very easy to go the other direction as you're supposed to. Thank you for correcting me and not just enjoying, again, the embarrassment. I think this one is correct now, right? Do we agree on that? Good. Let's move on. Almost the same thing, however, look at this. I jump back. Mean 280, standard deviation 10. New story. Mean 290, so it's a bit a teacher group which has a bit higher salary. However, the standard deviation is smaller. It's only 4. So they are distributed up to 298 and down to 282, roughly. Now, for this distribution, it's a distribution of teachers, it's a population of teachers having a higher mean salary than the other one, but a lower standard deviation. Even though they have a higher mean salary, let's try to find out what is the probability that a random one of these ones go beyond 300,000. That we would have to center with the 290, and we would have to divide not by 10, but now by 4, right? So now it's minus 10 divided by 4. It's plus 10 divided by 4. So it's whether the standard normal goes beyond not 2, but 2.5. Is that a smaller probability or a larger probability than before? Before we had, what is the chance of going beyond 2 in a standard normal? Now I'm asking, what is the chance of going beyond 2.5 in a standard normal? Smaller? Yeah, smaller, right? Because we go further out where it has sort of approaching 0. Let's find the number. Here is it. 1 minus p norm, 2.5. That would be the way I have phrased it. I've transformed it to the standard normal. So let's find the 1 minus p norm. It's only 0.6%. 0.0062. 0.0062. But if you could, using R, you wouldn't have to do this change of go to the standardized, because you could actually explicitly in R phrase that I'm looking at less than or equal, larger than or equal 300,000. That is 1 minus p, and then I should use the normal with the mean 290,000 and the one with the SD, the standard deviation of 4,000. Mean and SD are options to the p-norm function, and of course, it will provide us with the same number. So we could use this in R instead of doing this set calculation manually. It's clear if we want to use the tables of the book, we need to do this set transformation ourselves. And up here was the calculation from before, using the 300,000, mean of 200,000, and standard deviation of 10,000. And just to emphasize that, of course, this is exactly the same as removing in many the same number of zeros. May not be so much, of course, but actually it is the same. Good. Final simple example. Now we have yet another group of teachers. It's actually the same type group of teachers that we looked at a minute ago. Those with a mean of 290,000 and with a standard deviation of 4,000. Now the question is sort of phrased the other way around. It's a bit of technical, just to warn you that such questions can also be given to you. What interval covers 95% of all teachers' salary in this group? Well, we can almost answer this question just by our sketch and our knowledge, if we remember the knowledge I've told you now, right? Let's do the same sketch as before. Where we had this, let me do it down here. We had a mean of 290. We had a standard deviation of 4, 282. We had a standard deviation still of 4, 200. So I add 2 standard deviations and I subtract 2 standard deviations. And from the computations that I had from before, this is the answer then actually to the question, at least approximately. Because this interval from 282 up to 298 would be approximately 95%. Let me try to be exact now. What should the numbers be if it should be exactly 95%? That would sort of put it the other way around, right? What should I put down there to make it exactly 95%? I have to go a bit, actually it was, as you saw before, it's a bit above 95, so we have to move a bit into the middle, to the center, to get it exactly. It's not very much, but let's try to do it just for the fun of it. And to find a very important number in this course. Let's look at the point in the standard normal where we have exactly 2.5% here and exactly 2.5% here. The computations we did before, we had 2.3%, right? That's what let's find the point, and in fact it has a name. This is called set 0.025, and this would actually be minus set, and this is called set 0.025. Funny enough, in the book, it has a bit of notation here, which is sort of 1 minus the percentiles. It actually uses the right-hand probabilities in this notation. Nevertheless, it's notation of the book, and it makes a lot of sense when we move on to the way we're going to use this later. This is notation by the book. What are these numbers? What are the points in the standard normal giving exactly 2.5%? Let me find it in the table first. I'm going to look for 2.5% here. Wrong place. Here it was. If I look in the table and find 2.5%, I read off that it's 1 minus 1.96. Minus 1.96. If there's one number in this course you're going to remember, it's this number. Let me try to do Q norm 0.975. What is the point on the normal distribution that has 2.5% to the right of it, 97.5% to the left of it? 1.96, right? If we take the other one, which point has exactly 2.5% to the left of it. P norm is probabilities to the left of it, and Q norm is the exact inverse function of that, of the P norm. We, of course, get the symmetric, the other one, minus 1.96. So, we found that this one is minus 1.96, this one is plus 1.96. And then the exact answer to the question would be to say that we should take 290, not minus 2 standard deviation, but minus 1.96 standard deviation, and we should take 290 plus not 2 standard deviations, but almost 2 standard deviations. And that would give 282.84 and 297 point. I did a mistake here with the first one. It's 200. I have to go a bit. No, that's good. That's 84, and this one would be 297.84. I think so. Maybe I did a mistake here. We have to make it slightly smaller. I think that's what I did here. Yeah. So that makes sense. For everyday sort of practical work with this, I mean, it's not, of course, of major importance. I just wanted to be exact on this one. Usually we say plus minus 2 standard deviations are 95%. To be exactly, it's 1.96 standard deviations on each side. That gives exactly 95%, if we want, right? So that's what we found here. That was the end of this part.